Hello, class. So I wanted to go back over that problem that I attempted to go over today, just kind of in a better format for you, all right, and clear up any misconceptions. So we kind of talked about what the problem involves. We have different absolute value equations slash inequalities here, and we need to match them with their corresponding depiction on the number line. All right, so let's start with number one. All right, and these are all based on their cases. So if we just kind of have our cases ready, we'll be fine. So case one was the absolute value of x is equal to k, and that equivalent form was x equals k, or x equals, I don't know why I wrote k, x equals negative k. All right, then we have case two. Case two was the absolute value of x is less than k. This caused us to sandwich that x between the positive and negative signed k's there. And then we have case three, where the absolute value of x is greater than k. And that ended up with, x is greater than k or x is less than negative k. So let's use these cases and see if we can't determine what the solution sets of these should look like. So number one, the absolute value of x equals 4. Looks just like case 1. So that should end up being x equals 4 or x equals negative 4. So if I'm looking at the graph here, or the graphs, there's only one depiction of this sort of solution set type. So it's going to be x equals negative 4 and x equals positive 4, which is number 1 here. All right. So we got number 1 knocked off the list. Now what about number 2? The absolute value of x equals negative 4. I mean, we talked about in class that the absolute value of a value, so the absolute value of an input, would tell you that input's distance from 0. We also talked about how distance cannot be negative. So number 2, the number line depiction would actually be what we see here, which is no solution. All right, now moving on to number 3, and we got number 2 knocked out. Moving on to number 3. Number 3, the absolute value of x is greater than negative 4. All right, so what case does that apply to? Well, looks like it's case number 3. So case number 3, we would have the absolute value, so we'd have end up with x is greater than negative 4. Actually, in this case, while it looks like case 3, and this is what I wanted to talk about. So my mind instantly went to dealing with case number 3. The problem is, well, it's not really a problem, but the sort of idea is absolute values are always going to give us positive outputs. And the lowest output that could occur here is going to be 0. So pretty much every value would satisfy this. So every real number would satisfy number 3. So I'm looking for a all real numbers depiction on a number line, and I see that here. So the absolute value of x is greater than negative 4. Well, just because this is negative allows all real numbers to satisfy that. Okay. So we got number 3 knocked out. And again, that was the one that I stumbled on, and I was thinking about driving home today, and I was like, I got to clarify that for them. In any case, we come over here to number 4, and number 4 is a classic example of case number 3 here. All right, so we have a special case for that one, but this is a classic example of case number 3, and basically this is going to end up being x is greater than 4 or x is less than negative 4, just like we see here for case 3. So x being greater than 4 means we should start at 4 and shade to the right. X being less than negative 4 means we should start at negative 4 and shade left. So we're looking for that type of graph there. And number 4 fits the bill, and it looks like, this graph here fits the bill. But it also looks like this one can fit the bill. The only problem is that inequality sign is strict, so we can't include those 2 points there. So number 4 is going to go down here. All right, so moving on to number 5, that's a clear case number 2 here. So we're going to end up sandwiching x between positive and negative 4 here. So we're looking for a graph that sandwiches. I see two sandwich graphs here. So I need to take a look at my inequality sign, and the 4s are not going to be included. So this graph here is going to represent the absolute value of x being less than 4. So we have 1 through 5, and now we're looking at 6. Now 6 is another example of case number 3. The only difference with this one is going to be this inequality sign is going to include 4 and negative 4. So this should end up being x is greater than or equal to 4, or x is less than or equal to negative 4. So we're going to be shading out, and this is the clear winner of that sort of inequality. All right, so notice how negative 4 is included, positive 4 is included, and we shade away from the center. All right, with number 7, the absolute value of x is less than or equal to 4. That's case number 2, where we sandwich the x between positive and negative 4 here. The only difference is 4 and negative 4 will be included. So let's look for a sandwich. I see a sandwich here, and negative 4 included. So that's the winner for number 7. As far as number 8, the absolute value of x not being equal to 4, this is a challenging one. So this is very reminiscent of when we have just the absolute value of x equals 4. So the way we deal with this one, the absolute value of x does not equal 4, is going to tell us x does not equal 4, or x does not equal negative 4. So how do you write on a number line, how do you depict that something is not equal to that value? Well, you can put an open circle. That's my favorite depiction. I put an open, so if this is, say we have 4 and we have negative 4, I like to put open circles there. So open circle. And in fact, we'll do different colors for the different circles so you can kind of see. So open circle. If I'm going to shade everywhere that is not negative 4, I'm going to shade right on through all of this stuff here. And I mean, totally, I would technically shade in 4 as well. All right. So you would see me shading across this. So it's going to look like this. All right. And then I would shade on the other side as well. And then when I'm shading for positive 4, I'm going to shade everything but positive 4. And that even means shading through negative 4 as well. All right. So the only thing that kind of resembles this graph is going to be what we see here, in that we would shade. So with this sort of not including 4, you have an interval that goes this direction, and it also goes this direction. So not including 4 would pretty much be, that interval would look like from negative infinity to 4, and then we union from 4 to positive infinity. So you really just need to indicate at 4 somehow that it's not included. All right. And we do the same thing over here, only this one's going to be from negative infinity to negative 4, union from negative 4 to positive infinity. So that's why that looks kind of funky there. All right, I hope that clears any questions that you had regarding this particular style of problem. It's a really good problem that tests your understanding of the cases, and feel free to send me an email if you have any questions. Have a great day. Peace.